All right, today we're going to look at lesson 1.2, solving multi-step equations. Now, yesterday we solved one-step equations. What made them one-step equations? How many numbers were keeping the variable from being alone yesterday? One, which made it a one-step equation. But what happens when there is more than one number or more than one thing to do? Okay, it becomes a multi-step equation. And our essential question for today is, how can you use multi-step equations to solve real-life problems? Well, just like you learned in elementary school for PEMDAS, please excuse my dear Aunt Sally, I have an awesome way for you to remember the steps for multi-step equations, all right? The sentence is, don't call me after midnight. Now, here's the beauty of this sentence. You are going to see it over and over again this year. We may be all the way in chapter 6, and we're going to be talking about this again. So this is a way to help us organize our thoughts when we're looking at a multi-step equation. Where do we start? What do we do next? All right? So fill in those blanks beside each of the letters so you know what they mean. Now, the distributive property. If I'm going to do a distributive property problem, what's going to be in the problem? What's going to be a big indicator for me that there's the distributive property? Parentheses. So if you need that reminder, then just go ahead and put that at the end. Once you have filled in that blank, put the parentheses to remind yourself. Okay? After we've done the distributive property, or we've seen that there is no distributive property, we move on to combining like terms. Now, this is important. I want you to add at the end of that sentence, on the same side. Because when we're looking for like terms to combine, we're looking at either the left side of the equal sign or the right side of the equal sign. All right? So combining like terms is when they're on the same side of the equation. Now, let's review like terms. If I give you 2x and 3x squared, are those like terms? No. Because why are these not like terms? One of them has an exponent of 2. Remember, like terms are the same variable raised to the same power. So if you want to write that down and then put a nice little x over it to remind yourself, that is not considered a like term. What if I gave you 5x and negative 12x? Are those like terms? Yes, they have the same variable raised to the same power. What if I gave you 6 and 8? Are those like terms? Yes, neither of them have a variable. They're constants. So they are considered like terms, and you would combine them. Now, step number 3, we are not going to use today, but it's part of the sentence, so we're going to go over it, okay? The M stands for move the variable. Now, this happens when the same variable is on both sides of the equation. We've got to move one of them. Well, our goal, remember how we wrote our final answers yesterday? We like the variable on the left side. So when we're working the problem, if we can move the variable to the left side, that's what we're going to do, okay? Then we add or subtract. So we find that number that needs to move away from the variable with either addition or subtraction, and we move it. And the last thing we do is we move a number with multiplication or division. All right? So we're going to talk through this process, and let's go on to example number 1. Now, look at letter A. Do you see the distributive property in letter A? No. There's no parentheses, so absolutely not. Number 2, combine like terms. Are there any like terms on the same side of the equal sign that we can combine? No. We move to step 3. We already said there's not going to be the same variable on both sides, so we're skipping step 3. All right? And that leads me into adding or subtracting. Now, based off of what we did yesterday, what's the variable in letter A? N. Okay? How many things are keeping N from being alone? 2. All right? So the question is, which one do we move first? Which one do we move second? Okay, but according to our sentence, we're supposed to add or subtract first. So which number are we going to move?
3.
How are we going to move it? We're going to subtract 3 from both sides. Awesome. So we bring down what we have not used, and negative 2n equals 6. Now, multiply or divide. Multiply or divide. What are we going to move, and how are we going to move it? We're going to divide both sides by negative 2. So n equals negative 3. Now remember, equations can be checked. You can take your answer, go Go plug it back into the original problem and make sure you have the right answer. All right, now let's move on to letter B. Do you see the distributive property? No. Do you see any like terms that need to be combined? Okay, we're not moving a variable, so add or subtract. What are we going to add or subtract? 11. We're going to add 11 to both sides. Okay, don't be touching those calculators today. You don't need them. What's negative 21 plus 11?
Negative 11.
Negative 10, and it equals 1/2 C. Now, what has to be moved so that C is by itself? A fraction. So what did we learn yesterday is the quickest way to move a fraction? Multiply both sides by the what? The reciprocal. What's the reciprocal of 1/2? 2/1. Because we know, and you can just use 2 if you want, we know that a fraction times its reciprocal equals 1, and we know we don't have to bring that 1 down. What is 2 times negative 10? 20. Is this how we want our final answer to look? No. Remember, Ms. Johnson prefers the variable on the left, so that's how we're going to write our final answer. All right, letter C. Do you see the distributive property? Do you see no parentheses. Do you see like terms that can be combined?
Yes.
What are they?
Negative
2x and negative 10x. All right, perfect. So let's review. When we combine like terms, what part do we combine? The number or the coefficients. So negative 2 minus 10 is what? Negative 12. And of course, the x remains an x. We don't do anything to the x's. We bring down what we have not used. All right, what are we going to move next? Okay, we're at adding or subtracting, so we're going to subtract 12 from both sides, and we get negative 12x equals 6. How do we finish this problem? Divide both sides by negative 12. Now let me tell you, here's another preference of Ms. Johnson's. I don't want decimal answers unless the original problem starts with a decimal. Okay? I'm looking for fraction answers, but fractions that are always what? Reduced. Fractions have to be reduced. I even like you to leave your fractions improper, but they have to be reduced. So do not give me decimal answers unless the original problem started with decimals in it. So this 6 over negative 12 reduces to what? Negative 1/2. I don't care if the negative's in front of the fraction, if it's by the 1, if it's by the 2, as long as it's there somewhere. All right, now look at letter D. Do you see the distributive property? Yes, we have x plus 1 in parentheses, and right outside is a 3 waiting to be multiplied. All right, so let's review the distributive property. If we're going to distribute the 3, we have to do 3 times x times 3 times 1. Okay, so 3 times x is 3x. I like to go ahead and bring the sign down, and so then I'm just looking at the numbers. 3 times 1 is 3. Don't forget, the outside number has to be multiplied by everything on the inside. So if you've forgotten the distributive property, draw yourself these cute little arrows to remind yourself, okay? That moves us to step 2, combining like terms. Do we have any like terms to combine?
Yes.
What are they?
3 and 6.
3 and 6. So we have 3x plus 9 equals negative 9. All right, what would we do next? Add or subtract. So we're going to subtract 9 from both sides. So we have 3x equals negative 18. And to finish this problem off, we would divide both sides by 3. So what does x equal? Negative 6. Now, the next screen you're going to notice, number 1, I put D twice. So just change it to letter E. And every other problem, E, F, G, and H, all of these can be solved by following Don't Call Me After Midnight. Okay? So there's nothing on this screen that I have not taught you already. All right? So we're going to go through these as quickly as we can. We see the distributive property in letter E. We've got the 4 sitting right outside the parenthesis. So 15 equals 5 plus 8D minus 12. Again, we have to multiply the 4 by everything on the inside. The like terms are 5 and negative 12. So 15 equals, What's 5 minus 12? Negative 7 plus, we bring down what we have not used, so plus 8d. We then add or subtract. So we're going to add 7 to both sides. We've got 22 equals 8d. How do we finish off this problem? 12. Divide both sides by 8. Now look, there's an improper fraction. I'm okay with you leaving it improper. I want you to leave it improper. But will it reduce? Yes. What does it reduce to? 11 over 4. And of course, we just make sure that 11 fourths, we write D equals 11 fourths as our final answer. We don't have the distributive property in letter F, but we do have like terms. So negative 12 equals 9x minus 3x. 9x minus 6x, which is 3x, plus 15. What do we do next? Subtract 15. What's negative 12 minus 15? Negative 27. And that equals 3x. How do we solve for x? We divide both sides by 3. So what does x equal? Negative 9. And of course, we're going to write x equals negative 9. All right. Now look at letter G. Are we going to panic when we see letter G? No. We're going to do what twice? The distributive property. We're going to do the distributive property twice. So 5 times 3 is 15, minus 5 times x, which is 5x, plus 2 times 3, which is 6, minus 2 times x, which is 2x, and that equals 14. All right, did I lose anybody? We're just distributing, okay? Now, do we have like terms we can combine?
Yes.
Yes, we actually have 2 sets. We've got 15 and 6, and we have negative 5x and negative 2x. So we have 21 minus 7x equals 14. What would we do next? Subtract 21. Very good. So we have negative 7x equals negative 7. How do we finish this one? Divide both sides by negative 7. So what does x equal? Be careful. 1. Anything over itself equals 1. So a negative 7 over a negative 7 is equal to a positive 1. All right, letter H. Do you see the distributive property?
No.
Do you see like terms to combine?
No.
There's no variable to move, so what are we adding or subtracting?
3.
Okay, we're going to add 3 to both sides. 5 plus 3 is 8. It equals z divided by negative 4. How do we get z by itself? Multiply both sides by negative 4. All right. Of course, the negative 4's cancel. And what does z equal?
Negative 32.
Awesome. So z equals negative 32. Now listen, there was nothing new here. This was us just thinking through, don't call me after midnight. All right. Now look at letter I and letter J. What is the first thing you notice about both of these problems? They have the distributive property in them. But tell me, what are we supposed to be distributing in letter I? A fraction. Is there anybody in here that loves fractions so much that distributing with one makes you super, super happy? Okay? I don't believe you. All right? So, guess what? There's a shortcut. If you do not use this shortcut, couple things. You're wasting time, number one. Number two, you're giving yourself more opportunities to mess the problem up. Okay? So look at the statement right above letter I and J. When the number needing to be distributed is a fraction, multiply both sides by the reciprocal first. I want you to fill in that blank and I want you to highlight it. Okay? Let's get rid of that fraction as quick as we possibly can. So if you're looking at letter I, you told me a fraction. What's the fraction that needs to be distributed? All right, so we're going to instead multiply both sides by the reciprocal. What is the reciprocal of negative 6/5? Negative 5/6. I'm going to put the negative with the 5. So negative 5/6. So look at that. On the right side of the problem, it cancels. It equals 1. The fraction is gone. And all we have to bring down is x minus 3. Okay? What happens on the left, though? Does anything simplify before we multiply? You got the 6 goes into itself once, and you got 6 that goes into 66 11 times. So what's negative 5 times 11? Look at that. A problem that was multi-step now only has one thing left to do. How do we solve for x? We add 3 to both sides. Isn't that beautiful? So negative 52 is what x equals. So of course, x equals negative 52 is how we're going to write this final answer. All right. What happens on letter J? What's the fraction? 3/10. So instead of distributing 3/10, we're going to multiply both sides by what?
10 over 3.
10 over 3. So we can cancel it on the right side and only bring down a what? What's the only thing left to bring down on the right side? X plus 2. Will anything simplify before you multiply on the left? What? Look at us not needing our calculators. 3 goes into itself once, and 3 goes into 12 4 times. So what is 10 times 4? And once again, a multi-step equation now has just one thing left. What do we do to solve for x? Subtract 2. So what does x equal? 38. And of course, we're going to write that final answer as x equals 38. All right. Lastly, writing and solving an equation. Okay, some of you kind of missed this mark last night on the homework because you did x equals 195 minus 12. Well, that already had the x by itself. So be careful when you write these equations and make sure that you have an equation that looks very similar to the ones you've been solving. All right, let's read this. It says, you spent $50 on supplies for the bake sale. Let me ask you this. If you spent $50, does that go towards your profit or take away from your profit? Okay, so keep that in mind for just a minute. Each item, when you see the word each in a word problem, no, it's multiplication. Something's being multiplied by something else, okay? Each item sold for $2. After the sale, you had a profit of $180. So a profit of $180. How many items did you sell? Now there again, it's talking about the items that you sold. Do you know how many items you sold? So what does that become in your equation? Your unknown or your x, all right? So if you spent $50 on supplies, is that a plus 50 or a minus 50? That's going to be a minus 50. If each item sold for $2, what are you going to do with 2 and x? Add them, subtract them, multiply them, divide them. Multiply. So the question is, does 2x go after the negative 50 or does 2x go in front of the negative 50? In front. So the profit is, so 2x minus 50 equals 180. Now, does that look like something you've done before? Yes. So let's solve it. What do we do first? We add 50 to both sides. So 2x equals 230. And how do we finish this problem? Divide both sides by 2. So x equals 115 what? Items. Don't forget it is a word problem. So 115 items. All right? Last thing. 8 plus the quotient of a number and 3 is negative 2. Write down what you think that's going to be. What do you think the equation is going to be? 8 plus the quotient of is the answer to what kind of a problem? Multiplication. So it's the not multiplication, sorry. Division. I was like, yes, division, right? So what are you doing with a number and 3? You're dividing. So x divided by 3 is equals negative 2. All right? So we're going to subtract 8 from both sides. X divided by 3 equals negative 10. And how do we finish off this problem? Multiply by 3. So x equals Now, is there a label necessary on this one? No, there's no label. And that is lesson 1.2.